Hello. In this video, I want to introduce the idea of convergence. To get an idea about what this means, let's look at this sequence. So suppose I start with the number half. The next number in this sequence is half of this, which is 1/4. And let's say the next one is again half of this one, which is 1/8. Next one is half of 1/8, which is 1/16. And the next one is half of 1/16, which is 1/32, and so on. So I have a sequence. That where the numbers keep getting halved, and so on. So the numbers get smaller and smaller. And suppose that I imagine that this sequence just carry on forever, so that I have lots and lots of numbers, never ending sequence of these fractions that keeps getting halved. Now I want to think about adding up all these numbers. If I add these two numbers, if I add half to 1/4, my answer would be bigger than half, of course. If I add the next number, I'll get a big answer. If I add this one, my answer would get bigger. So that's obvious. If I keep adding numbers, my answer would get bigger and bigger. Now suppose that I keep adding more and more and more, and I don't stop adding. I just keep going on and on and on. Now the question is, will my answer just keep on increasing and get bigger and bigger? Or since these numbers are getting smaller and smaller, is it possible that my answer get closer and closer to some fixed number? And in this case, let's have a look. We can actually have an idea of what would happen to the answer for this particular sequence. So to see what happens, we can think about representing this sequence as a number line. So let's say that's a number line, and let's say that mark is for the number 0, and let's say this is for the number 1, and number 2 is somewhere down there. Okay, so if I start with the first number, which is just half would be in the middle, would be there. That would be half. Okay, so the length from here to here is half, actually. That would be half. If I add 1/4, to half, you know, half plus 1/4 is just 3/4. But I can think about the 1/4 as half of half, right? Now, but it so happens that this length here from half to 1 is also half. So I can think of 1/4 as half of this length. If I take half of this length, this would be 1/4. From here to here, this would be 1/4. So adding half to 1/4 is the same as adding this to this, which is 3/4. Okay, so I would simply get the answer of adding half to a quarter by cutting this part into half. So this is half plus 1/4 gives me this. If I now want to add 1/8, right? If you look at this, it so happens that this is 1/4. This is the same length as this. So 1/8 is half of this. So I can add 1/8 simply by cutting this into half, and that would be 1/8. And this would be 1/8. So when I add 1/8 to a quarter to a half, meaning add up all those three terms, I would actually get this point as the answer. My answer would be exactly there. Now you can already see that there's a pattern, okay? And to add the 1/16, likewise I just have to cut the remaining section into half. That would be 1/16, and that would be the answer when I add up this, and this. And we can keep going. 1/32 would be obtained by cutting this into half. Okay, and adding 1/32 would bring me to that point on the number line. Now if I keep adding more and more terms in this sequence, it's the same if I keep cutting the remaining section in this number line up to 1 into half. If I keep cutting this remaining part into half, and then half, and then half, and I keep doing that as I take more and more terms here, I just keep cutting the part that remain until that goes from the mark there until 1. I just keep cutting that remaining bit into half. I just keep halving it. Now, but if that is the case, it means that I would never go beyond 1. I would get closer and closer to 1, that's for sure, because I keep halving the remaining distance to 1. But I'll never go beyond 1. But I would definitely get closer and closer to 1. And in fact, it will just keep getting closer and closer. I would not actually stop before 1. If I keep adding this, I would never actually stop at some distance before 1, because I can always keep halving until it's even closer than that. Okay, then whatever distance you can think of before 1. So what this means is that if I keep adding more and more of this forever, now we use this symbol here to represent infinity, which kind of means forever. Infinity, meaning I keep adding more and more terms forever, or it means a number which is extremely big, so big that you can't imagine how big it is. Okay, so if I keep adding more and more terms, my answer would just get closer and closer to 1. And if I imagine adding an infinite number of terms, the answer should eventually approach 1, so close to 1 that I can't tell the difference from 1. Okay, that's kind of the idea. So what just happened was that the answer actually converged to 1, or it reached 1 as the limit of this sum. So there are a few ways to describe this situation. I can say that the answer of summing up this sequence converged to 1. Okay, or I can say that the answer tends to 1, or I can say that the answer approaches 1. I can also add as the limit, or I can say that 1 is the limit of this sum. So there are quite a few ways we can describe this situation, but The main point I want to highlight using this example is that is this possibility that I can keep adding numbers forever, an infinite number of numbers, if you like. I can keep adding numbers forever, and yet it is possible that the answer does not keep getting bigger and bigger beyond a certain number. All right, that the answer actually get closer and closer to a fixed number instead of getting bigger and bigger forever. So there is this possibility, and this is the idea of a convergence, that the answer would get closer and closer to a particular number.